Gram stain. Bacteria or viruses?
Bacteria.
Why?
Peptidoglycan.
What does peptidoglycan have to do with it?
It retains the crystal violet.
Wow, you're being super detailed already. Okay, so the gram stain, we're dyeing bacteria, right? Now, why would I not stain a virus?
A lot of reasons.
Because it has to really contain the dye.
Okay, lots of things.
You can't even see the color because you have to use an electron microscope.
Yeah, to see a virus, first of all, you have to look at it underneath an electron microscope. You can't see color, so, oh cool, I did a gram stain, but I can't even tell. That's another reason.
Does it have peptidoglycan?
Yeah, we're staining the peptidoglycan, and does a virus have peptidoglycan? No, what does it have? A capsid, okay? So these are strictly for bacteria that we do a gram stain.
Capsid wouldn't stain at all.
Don't know about that.
But all viruses have them, so it still would be useful for differentiating.
True. Yeah. But we're not always doing the gram stain. Okay, that leads me to our next question. Why do I do a gram stain?
To differentiate between microbes.
Yeah, so if someone comes into the hospital and they're sick, I take a swab of their throat and I do a gram stain, just from it turning red, what do I know?
Which gram?
Gram negative, right? So then 50% of my available diseases that it could be the person has, any disease that's gram positive, I know immediately they don't have that. So I can narrow it down by 50% just from the gram stain. What's another reason? This reason's kind of too obvious for you guys to usually answer it. If I take a swab of your throat, put it on a slide, look at it underneath the microscope, what do I see?
Oh,
It's
contrast.
transparent.
Absolutely nothing, right? Because it's all transparent. So the gram stain, first of all, I want to see it. Second of all, just from doing a couple steps, I can learn a lot about the microbe. Good? If you guys go into any microbiology fields, you'll get so sick of doing the gram stain because it's all you do. There are people at the hospital over there, and they just are so good at it. They're just like pouring stuff on sinks, and they can do it like super fast and not mess it up. So they do like hundreds of them a day. So it's extremely effective. We study against bacteria, right? What are the two kinds of bacteria?
Gram positive and negative.
Yes. Remember how I said be super detailed? Here's an example of that. If I saw a question about gram stains on the test, I wouldn't just talk about gram stains. I would first show that I really know the difference between gram positive and negative. See, because you know that has to do with gram stain, right? So first, prove that you understand the difference between gram positive and negative, and then get into the gram stain. Does that make sense? So I'm going to do all of it right now. Okay? So gram positive and gram negative. Someone remind me what the difference between these two are.
Gram positive has a thicker peptidoglycan layer, and gram negative has a thin peptidoglycan layer and an outer membrane.
Just wondering, does anyone remember how many layers of peptidoglycan gram positive has?
30.
Wow, you guys are good. You don't really need to know that, but if you put that on the test, you'd be like, dang, that person's smart. So I would, if I were you. How about gram negative?
One.
Yeah.
And with the peptidoglycan layer, it's the M sugars that have the
You don't really
tetrapeptide
need to know
interridges.
that.
No.
That's like, I always draw that and people point it out. It's an upper level thing that you need to know.
Okay. Well,
Again, I don't think it hurt to put it on there, but you don't have to. Okay, so we have peptidoglycan in both. A lot of layers in gram positive, not so many in gram negative. Do you have a question?
Both have like a lipid bilayer.
They do have a lipid bilayer. Where?
I mean,
Okay, so
plasma membrane.
I would say lipid membrane. Technically, yes, it's a plasma membrane. I just don't want to throw a bunch of words at you. Lipid membrane here?
Top and bottom.
Top and bottom. Personalness, that should be review, right?
Yeah.
Okay. Let's take a zoom in of peptidoglycan. What is it composed of? Sugars. How many sugars?
2.
2 repeating sugars. That's how I'd say it. What are their names?
G and M.
G and M. Good job about going to him about the case study already, though. That will help a lot. I wish I did that when I was in class, but I didn't. It wasn't like popular to do then. Okay, so we have our 2 repeating sugars. Is that it? Ooh, that was a really good word. Who said that? Does anyone else know the answer? Tetrapeptide interbridges. It's a long word, but let's break it up. Proteins are made of, you guys know? Amino acids, and there are 4 of them that come off this. So 1, 2, 3, 4. So that's the tetra part. Tetra. What are they made out of? Protein, so tetrapeptide. Okay. Are they in between or on the outside? So inter. And then they're connecting 2 things that are separated, so like a bridge. So tetrapeptide interbridges.